Welcome to Class 10 AI Exam Ready, your smart guide to mastering CBSE Artificial Intelligence. Clear concepts, exam focus, board-ready success. Let's get started.
Hello everyone and welcome back. Today, we are diving deep into one of the most important units for your Class 10 AI exams, Advanced Concepts of Modeling. Now, from an exam point of view, this unit is absolutely critical. Why? Because it's the foundation. It's how AI actually, how it thinks and learns. So let's get right into it.
Have you ever really thought about it? It feels a bit like magic, right? You watch one crime thriller on Netflix and boom, your whole feed is suddenly full of detective shows. Or you just type dog into your phone's photo gallery and magically every single picture of your furry friend just pops up. How in the world does your phone know? What's the secret sauce behind all of this?
Well, I'm here to tell you it's not magic. The secret, the powerful engine running behind the scenes of all this amazing tech, is something we call AI modeling. And today, we're going to pull back the curtain and see exactly how this whole thing works.
All right, let's jump into our first big topic. Whenever someone builds an AI, they have to make a really basic choice about how that AI is going to think. You can imagine it like standing at a crossroads with two main paths leading to what we call intelligence.
So, these are the two paths. On one hand, you've got the rule-based approach. This is kind of like giving the AI a super strict rule book. For every situation, there's a specific rule. Like, if a user says hello, then you reply, "Hi, how can I help you?" It's very simple, very rigid, it can only do what it's been told. But on the other hand, we have the learning-based approach, and this is where the real magic happens. Instead of a rule book, we give the AI a mountain of data, and it figures out the patterns and rules all by itself.
Now that rule-based way is useful for simple things for sure, but it can't learn, it can't adapt. The real power, the tech behind your Netflix recommendations and your photo gallery, that's all on the learning-based approach. So for the rest of our session today, this is where all our focus is going to be. Okay, before we get into the details of learning-based models, we need to clear up something that confuses a lot of students, especially in exams, and that's the difference between AI, machine learning, and deep learning. You hear these words thrown around all the time, but they're not the same thing. So let's make this crystal clear once and for all. The best and easiest way to remember this is to think of it like a family. Artificial intelligence, or AI, is the big family name. You can think of it as the grandparent. Machine learning, or ML, is one of the children of AI. Let's say it's the parent. And then deep learning, or DL, is an even more specialized, super smart part of that family. It's the gifted child.
And this diagram right here shows that family relationship perfectly. See that big outer circle? That's artificial intelligence, the whole big field of making machines smart. Then, inside that, you have machine learning, which is a part of AI, where machines learn from data, and then nested right inside ML is the smallest, most powerful circle, deep learning.
Okay, students, exam point of view, this slide is super important. Let's lock these definitions in. AI is the big idea of making computers act human. Machine learning is a way to achieve AI by letting machines learn from data, and deep learning is a special kind of machine learning that uses tons of data and something called neural networks. So the key thing to remember is this: DL is a part of ML, and ML is a part of AI. Got it? Perfect. All right, so now we know what machine learning is. But how does a machine actually, learn? Well, just like us humans, machines have different ways of learning. There are three main styles, and we're going to break down each one.
First up, we've got supervised learning, and you can think of this one as the studious pupil. The key word here is supervised, like there's a teacher. The machine gets data that already has the correct answers. We call this labeled data. Think about it like you're studying for a math test using a guide that has all the problems and all the solutions right next to them. The machine learns by looking at both the question and the answer together.
A perfect real-life example of this is the spam filter in your email. How does it know what's junk? Well, it's been trained on millions of emails that people like you and me have already marked as spam or not spam. It looks at all that labeled data, learns the patterns, and then makes a prediction on any new email that comes in.
And here's a great visual example. The model is given a bunch of pictures, and each one is labeled. This one is an apple, this one is a strawberry, and so on. The AI studies these, learning what makes an apple, its round shape, its color. After it's trained, if you show it a brand new picture of an apple that it's never seen before, it can correctly say, "Hey, that's an apple." That's supervised learning in a nutshell.
Next up, we have unsupervised learning, and I like to call this one the curious detective. This is the complete opposite of what we just saw. Here, there are no labels, no answer keys. You just give the machine a huge pile of data and say,
Go figure it out. The machine's job is to find patterns and create its own groups, just like a detective who only has a bunch of clues and has to figure out how they're all connected.
Let's go back to our Netflix example. This is a classic case of unsupervised learning. Netflix doesn't start with labels like people who like sci-fi. It just looks at the raw data of what everyone is watching. It might notice that a whole bunch of people who watched movie A also watched movie B. So it puts them all into a group, a cluster, all by itself. And that's how it recommends your next show.
Look at this diagram. Imagine a supermarket feeds all its sales data into the model. There are no labels, just who bought what. The AI crunches the numbers and might discover two distinct groups of customers: people who mostly buy groceries and people who buy other things. It figured out this structure all on its own. That is the power of unsupervised learning.
And our third and final style is reinforcement learning, also known as the adventurous gamer. This is totally different. Here, an AI agent learns by doing things, by interacting with its environment. It learns through pure trial and error. When it does something good that gets it closer to its goal, it gets a reward, like a point. When it makes a mistake, it gets a penalty. The whole point is to figure out the best strategy to get the maximum number of rewards.
The classic example is an AI learning to play a video game. When it starts, it's clueless. It just presses random buttons. But if it accidentally scores a point, it gets a reward. If it loses a life, it gets a penalty. It plays millions and millions of times, and over time, it learns the perfect strategy to get the highest score possible, often becoming way better than any human player.
So we've talked about these incredible learning models, especially deep learning. But what's actually going on inside? What does the brain of the AI look like? Well, the answer is something called neural networks.
And this is the one single idea you need to remember. Artificial neural networks are basically computer systems that are inspired by how our own human brain is structured. Just like our brain has billions of tiny neurons that talk to each other, these networks have interconnected nodes that work together to recognize patterns. It's a pretty cool concept, right?
So, at a very simple level, how does it work? Well, it has layers. First, there's the input layer, which takes in the data, like say all the pixels from that photo of your dog. That data then gets passed into the middle, to one or more hidden layers. This is where the real brain work happens, where it finds all the complex patterns. And finally, the result comes out of the output layer, which gives you the final answer, the word dog. This is the basic engine that powers all of deep learning.
Phew, okay, we have covered a ton of information today. From the 2 paths of AI to the 3 learning styles, and even a peek inside the AI's brain. Now let's put it all together in one single slide that is going to be your best friend for revision. All right, everyone, this is it, your exam cheat sheet. Let's do a super quick 1-minute revision. Look at the data type. Supervised needs labeled data. Unsupervised works with unlabeled data, and reinforcement learns by interacting. It has no starting data set. Now, how do they learn? Supervised has a teacher. Unsupervised finds patterns on its own, and reinforcement learns by trial and error. And finally, what's the goal? Supervised is for predicting. Unsupervised is for discovering, and reinforcement is for maximizing rewards. Please, I'm telling you, pause the video here, take a screenshot of this table. It's extremely important for your exams. And that brings us to the end of our chapter on advanced AI modeling. If you've understood the difference between rule-based and learning-based models, if the AI, ML, and DL family is clear, and if you can explain the 3 learning styles, then trust me, you've built a super strong foundation for your board exams and for understanding the incredible technology that's all around us. Well done, everyone.